Hello, students. Today, maybe, there we go. We're going to talk about level of measurement, but first I'm going to talk about analysis. And here we go. What is poetry? Oops, wrong class. What is statistical analysis? It is the objective interpretation of social and human phenomena. We are doing empirical data analysis. That means it can be proven by numbers, which is quantified data analysis. Some examples of this are population trends. City managers certainly like to see this data. The degree of stress, students in school or workers and their salaries or their working conditions, and voting tendency. Well, we got an election coming up in November, so they are running polls constantly in Washington right now. Quantitative methods. Data is information. What we do in statistics is collect this information systematically and scientifically. Only then can you interpret it correctly. We use quantitative methods. That just means that you're using numbers and you're analyzing the data numerically. The number values are codes for each answer in a question on a survey, or each value label in a data set. Answers are in questionnaires. Value labels are in data sets. They're the same thing though. We are going to use SPSS this semester. That is the statistical package for social sciences. There's two views that you're going to be looking at in the data window. One is variable view, which I'm sure you're very familiar with because you may have already been building your database. This displays information about each variable. And this is where you define or create a data set. The other view, and both of these views in SPSS are like way down here in the lower left corner. There's two tabs. One says data view, the other one says variable view. Data view is where you enter data. You know, it shows the cases and the variables. A very important warning. Never work on a data set directly after opening it from an email. You know, I know you're all into Google Docs and you don't have to email back and forth reports. You just open it up and do it. But SPSS is not so intelligent like that. So you might be mailing or emailing data sets back and forth to each other. So when you get a data set from a group member, always open it and then go to File and Save As, and just save it with the same file name and, you know, change the number, add a sequential number. Like if you've opened up the database and the number after the name is 3, then Save As and make it 4. Excuse me. Populations and samples. People who do survey projects work with both of these. A population is the collection of all units you are considering. For example, all CSUSM students. The sample in that regard would be any subset or subgroup of the population. For example, only 500 of all CSUSM students. It's too impossible to survey 18,000 students. Too costly and it would take too much time. So the whole gig with statistical research is that you can only survey a sample of maybe 500 students and run your analysis and then generalize those results to the greater population. Wow, that was really well said. Thank you, Professor Kilpatrick. In order to use a sample that you're going to generalize to the greater population, it must be what is called a random representative sample. That just means that the random aspect of it is that each unit, whatever that unit is, it might be a student in your sample. I'm sorry, the student in the population has an equal chance of being selected for the sample. So if you have 18,000 students at CSUSM, each of them has an equal chance of being selected to be interviewed for that smaller sample. It also has to be representative. The sample has to be stratified in such a way that every possible category of student will be pooled, and you will select your sample from that. And here's an example, a stratum or a group of students. This would be one strata in a huge sampling design. Students who are Latino, juniors, communication majors, full-time students, and they are employed. So you may have, 185 that fit that category out of 18,000 students. And you will randomly select as many as you need from that 185. Totally confusing? Right on. That means I'm doing my job. Variables and measurement. A variable in a data set starts out as a question. For example, what is your age, or how old are you? In SPSS, it becomes a variable, the SPSS data set. So the question, what is your age, becomes respondent's age. And the answer categories that you might set up in SPSS are these four ranges, 18 to 29, all the way to 70 and above. Sex, questions about sex, income, education, satisfaction, they can all be variables. They can all be questions on a survey, and they can all be variables in a data set. When they become variables in a data set, they have to have coded or numbered responses or answers. And here is the point of this whole lesson. There's 3 levels of measurement for variables. The easiest one is nominal level. And in this case, nominal variables, the answer list must be exclusive. And that means if you fit into one answer, you can only fit into that answer. You cannot fit into another answer. Unless, of course, there's an instruction on the questionnaire that says check all that apply. But that's kind of rare. The other condition is that the answer list must be exhaustive. You'll see in the data set that we're going to use for some assignments that the race variable, the answers are white, black, and other. That's not an exhaustive list. So when you create answer lists, you have to have, within reason, enough answers so everybody can pick something. The third thing about nominal variables, which makes them easy to identify, is you cannot rank or order the answer list, right? Here's an example. The respondent's zip code, these 3 zip codes, and then the answer of other, which is, a really shortened version of an answer list. But if you live in 92025, you cannot live in 92008. That's exclusive. And adding the 4th answer of other kind of takes care of the exhaustive characterization. And you'll see that in a little bit, what other does. Because you don't want to make an answer list with 55 answers in it. That's obviously overkill. Okay, so The next level of measurement is ordinal. It has the first two characteristics of nominal. The answer list must be exclusive and exhaustive. But with ordinal level variables, you can rank or order the answer list. But the exact difference between any two answers in the ranking is unknown. And here's an example of what's called a Likert scale, sometimes used to represent value labels or answers in a questionnaire or a database. So the variable in this case in the database, it has a label respondent likes statistics, and the answer choices are dislikes very much all the way to likes very much. And you can see that these answers have numerical values attached to them. And you can probably also see that if they like statistics, that's probably more liking than dislikes very much, right? But you don't know exactly how much more. That's what makes it ordinal. You know, you can see that there's a ranking in these four answers, but you just don't know the exact difference. You know, if somebody picks likes, it's not 5 times as much liking as dislikes very much. You don't know that. Unlike interval level variables, which also have to be exclusive and exhaustive, and you can also rank or order these answer lists, but the exact difference between any two answers is absolutely known. And here's an example. A variable with the label the number of pets respondent owns, and here are some answers: 1, 2, 3, 4, 5, 6. Each of these answers has a numeric value in front of it, and you absolutely know the exact difference between any two of these answers. If somebody asks me how many pets I own and I say 2, and the next person they ask says 5, you know the exact difference is 3. That's the difference between interval and ordinal. Interval is really easy to identify. Ordinal gets kind of funky, which you'll see when you start doing the assignments for this week. One of them is a level of measurement problem set, which I'm going to show you in another video. And the other one, you're going to work with an actual set of database variables, and I want you to assign level of measurement to all the variables. And that also will be a different video. Okay, so that was super fun. I don't know how you feel about it, but it made my day. And I'll see you in the next video. All right, happy Monday.